In the previous video, we had learned about the first point of difference rule, and that's very important to what we're going to deal with in this one. So the first one is if there is more than one of the same substituent present in the compound, what would its name be? So as per our rules and regulations that we've learned till now, we need to first number the carbon chain such that the the substituents occupy a lesser position. So, or rather they're attached to the carbon whose number is less than the others. Other way of notation. So first let's write down the numbering. So this will be our main chain because it has 4 carbons and it has 2 substituents, and these CH3 and CH3 are called as methyl groups. In the first, when we discussed about the basic introduction of the IUPAC nomenclature, we'd also studied about these substituents. So if they have one of the hydrogens is removed and they join the main chain, and they are considered substituents, and their names are similar to the word root. Only thing is they'll be having the word letters YL attached to it. So CH3 is methyl, C2H5 is ethyl. And propyl will have 3 carbons, and the hydrogens out of the hydrogen, as such it would, propyl is CH2, CH3, CH3. So this is propane. So when this changes to CH2 and it is attached to another chain, it's called as propyl. We discussed this in that video. So we know that there are 2 methyl groups attached to this particular carbon. So 1, 2, 3, 4 can be one numbering, or it can be 1, 2, 3 and 4. But because 2 is obviously lesser than 3, 2 is considered. Now, in this compound, you have 2 methyl groups, which means it has to be, that also has to be denoted. And so we will use di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and so on. So here we have 2 methyl groups, which means, and it is in the first of all it's in the second position. So 2, 2 dimethyl. So these 2 are denoted. Then since this particular compound has 4 carbon atoms, butane. That's the word root. Now here in this also it has 2 methyl groups, so it is going to be di. Now let's write the number 1, 2, 3, 4, 5, 6, or it can be 1, 2, 3, 4, 5, 6. Now based on what we learnt about the first point of difference rule, let's write down the substituents. It's in the second and the 4th position, or it can be in the 3rd and the 5th position. And based on the first point of difference rule, this will be the right one, this will be wrong, because the numbering, the lesser number is what is considered. So the name for this particular compound would be 2, 4 dimethyl hexane, because your word root is, it has 6 carbon atoms, so hexane, and it's an alkane, right? So ane. Next, this compound, now if we count 1, 2, 3, 4, 5, 6, it's same as 1, 2, 3, 4, 5, 6. So for ease, we will take this one as the main chain. So you have 1, 2, 3, 4, 5 and 6, and backwards would be, and anyways we know that since 3 is lesser than 4, 3 is going to be considered. Now here CH2CH3 or C2H5 is an ethyl group. Okay, so which means we will have to write it as 3, 3 diethyl hexane. So here in this particular part, what we had is we had more than one of the same substituent, and their number is denoted by using di, tri, tetra, penta, hexa, etc. And the numbering is done based on whatever rules we have learned up until now. Okay. So when we have different substituents in the particular compound, there is another rule that has to be followed. First, let's number this and figure out the numbering of this particular chain. So first of all, 1, 2, 3, 4 and 5. There are 5 carbon atoms here and there are 5 here as well, and both have the same number of substituents, and that is 1. So if we consider this chain, this and this will be substituents, and when we consider this as a main chain, this and this will be the substituents. So they have the equal number of substituents, so it does not matter which one you pick. So I'm picking this one because it's easier since it's in like one line. So this will be the first carbon, this will be the second, this will be the third, fourth and the fifth. Similarly, we also will be considering the numbering from right to left. So 1, 2, 3, 4 and 5. So the substituents, when I use this thing that is from the left to right, are in positions 3, 3 and 4. Whereas when I when I went from right to left, the substituents are in the position 2 and 3. So obviously we will be taking this numbering and not this one because this is lesser, and that's what we learned in the first point of difference rule. So here what we will be doing is, we'll be taking, and let's first look at the substituents that are present. So you have 2 methyl groups at position 2 and 3, and we have an ethyl group in position 3. Okay, so you have ethyl in position 3 and you have 2, 3 dimethyl. So since we have 2 different substituents, we will be putting them alphabetically, and this is excluding this part. So ethyl, and then you have methyl. Okay, the di, tri, tetra, penta, hexa is not considered over here, but the name of the substituent alone is considered. So you have 2, 3 dimethyl and 3 ethyl, and this is a pentane chain because it has 5 carbon atoms. So the name of this compound will be 3-ethyl 2,3 dimethyl pentane. So we have 2 substituents, that is 3 substituents, 1 ethyl and 2 methyl groups. So E comes before M, and so ethyl will be placed before methyl. Again, we'll do another example. Hopefully it clarifies it helps you understand it even better. So here in this compound, 1, 2, 3, 4 and 5. Okay, that's one chain which is possible. 1, 2, 3, 4, 5, 6 is possible. 1, 2, 3, 4, 5 again is possible. 1, 2, since these are all methyl groups, irrespective of where we start from, you'll have 6. So our longest chain is from here. It starts from this carbon and goes up to this carbon. So it includes these carbon atoms. So here we have substituents. You have methyl, that is CH3, and then ethyl. Okay, now we need to number it in such a way, first of all, that all the substituents get less number. So here CH3, 1, 2, 3, 4, 5 and 6. So this is one way of numbering. And here your second carbon is having 2 substituents, so 2 times, and then the third carbon is also having 2 substituents, so 3 and 3. Now when we go backwards, that is when we start from here, 1 2 3 4 5 and 6. So this is again based on the first point of difference rule. So you have fourth carbon having 2 substituents and the fifth carbon is having 2 substituents. So based on that rule, we know that 2 2 3 3 is the right numbering. So the one in blue is the right numbering. And first of all, in the second position, you have 2 methyl groups. And so you'll be writing 2, 2. There are 2 methyl groups, and there's also this group which is attached to the fourth carbon, which is also methyl. So third carbon, 2 2 3 trimethyl. Okay, next you have an ethyl group attached to the third carbon, so 3 ethyl, and the total number of carbons is 6, so hexane. So these are the substituents. This is the word root or the parent, the main chain, the longest chain. So after we learned that we need to order this in such a way that the substituents are in the alphabetical order, and we will be ignoring the di, tri, penta, hexa, whatever. So the name of the compound will be 3-ethyl 2,2,3 trimethyl hexane. Actually, let me just write here. So when we have a substituent, or rather when we have multiple substituents or different substituents present, they're numbered in such a way that they follow the first point of difference rule, and they are written in the compound in the alphabetical order. For example, had there been a propyl group here, actually then technically the chain length would have changed, but assume that you have a methyl and a propyl group in the chain. Then the methyl group will be written first, and then you'll be writing the propyl group. So suppose let me just so CH2, CH3, CH2 1 2 3. Okay, and we are changing this to CH2, CH3 first of all. So 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7 8. Let's assume this is the longest chain, CH2, CH3. Okay, now here this is the propyl chain. Okay, now instead of it being 3-ethyl, it would have been 3-propyl, and 2,3-dimethyl would have come first. So 2,3-dimethyl, because M comes before P, so dimethyl, 3-propyl. I forgot how many carbons I put. 1 2 3 4 5 6 7 8 octane. So here we've ordered it in such a way that we know M comes before P, right? So to ensure the alphabetical order is maintained, we have changed it in such a way that alphabetically the substituents are written down in the IUPAC name. So when more than one substituent of the same type is present, then we are using prefixes like di, tri, tetra, penta and hexa. And when there are different substituents present, we are first numbering them, and then we'll be writing them in the order of their, or rather in the alphabetical order. In the next video, we will be discussing about different substituents being present and what if they're complex substituents which are present. Do check it out.